Hey guys, I know this kind of looks like barf, right? Like a lot of things happening, a lot of variables, big old fractions, okay? Guess what? We're actually going to get rid of the fractions, okay? So we are solving rational equations today, okay? And let me show you kind of a simplified version of the strategy we're going to be using, okay? Here's this problem with a big old fraction, right? And I'm like, oh, I don't really want to deal with that, right? So one strategy would be to multiply both sides by 5, okay? As long as I multiply both sides, I'm good, right? And then what happens is the 5's cancel, right? This turns into a 50, that's fine. And I end up with this guy, which might still be a little intimidating, but the big old fraction is gone, right? So we're going to do something similar here, except it's like, this is a little more complicated than just a 5, right? So my goal here is to figure out what I need to multiply by to be able to have those fractions, the denominators cancel, right? Okay, so the first thing I'm going to do is factor, okay? Now, if you need a factoring review, if I'm going to do it pretty fast, so if you're like, ooh, how did she factor that? I will link a few factoring videos for you, okay? This here is a difference of squares, so it's going to factor to x plus 3 times x minus 3, okay? This guy is factored. This guy is going to factor to x squared minus 9 times x plus 1, okay? And then it's going to factor down more to that x plus 3 times x minus 3 times x plus 1, okay? So we just factored things. I'm going to, hold on, where's my paper? Oh, here it is. Okay. This is the same problem, just with it factored. So we don't have to be looking at all my marker marks, okay? So same problem, just now my denominators are factored, okay? So now my goal is to find what we call the LCD, the least common denominator, okay? Now you're probably like, oh, that sounds kind of familiar. Well, it probably sounds familiar because back when you would add and subtract fractions, which was probably like your favorite thing ever, right? When you had different denominators, you had to find the least common denominator, right? To be able to add or subtract them. Now, in this case, it would be 6, right? That's the smallest number that they both go into. So we got to figure out what the smallest number all these guys go into is, right? So the smallest one they go into is going to be basically them multiplied together, right? But with a little twist. So I know for it to have a common denominator, I need that x plus 3. I also need the x minus 3, right? Now, x plus 3 I already have, so I don't need to have it again. I already have the x plus 3, the x minus 3. I do need to account for that x plus 1, okay? So that is my least common denominator, okay? So let's see what happens when I multiply both sides by this least common denominator, okay? So I'm going to multiply this side. We are multiplying by x plus 3 times x minus 3 times x plus 1. Okay, I'm also multiplying this side. Remember, I'm multiplying the whole side, okay? So it's going to distribute to both of them. So I'm multiplying both of them by the LCD, okay? So I'm multiplying by x plus 3 times x minus 3 times x plus 1. Guys, I know it's a lot of writing, but it's going to be worth it because we're getting rid of the fractions, okay? So x plus 3 times x minus 3 times x plus 1. Whew! Okay, now watch what happens. This is the fun part. X plus 3 and x plus 3 cancel. X minus 3 and x minus 3 cancel, okay? So for that guy, I'm just left with x plus 2, that one, times x plus 1. Whew! That's not too bad, right? Plus, this guy and this guy cancel. So I am left with 5 times x minus 3 times x plus 1. Okay? Equals, this is the real fun one, guys. This and this cancel, this and this and this. And I am just left with that 2x minus 16. What? Pretty exciting, okay? All right. Now, my whole goal is to get x alone, right? I want to know what x equals. So we're going to multiply this out and see what happens, basically, okay? So we're going to FOIL this. So I have x squared plus x plus 2x, that was that, and that, plus 2, okay? And then I've got 3 guys being multiplied here, so if I multiply that 5 in, I get 5x minus 15, right? And then we're multiplying that with this guy, right? Which will give me plus 5x squared plus 5x. And then, sorry, this is like not the most neat thing here. Minus 15x minus 15. Okay, hopefully you can see I foiled that, okay? Equals 2x minus 16, okay? Okay, this looks a little scary. Now we're going to combine like terms. So I've got these x's and these x's, right? And I've got an x squared here and an x squared here. And then I've got that plus 2 and that minus 15. Okay, so let's add these x squared. So that's going to be 6x squared, right? And then I've got 1x plus 2x plus 5x, which would be 8x, right? Minus 15x, which is going to be negative 7x. And then we've got plus 2 and minus 15, which is going to give me a negative 13. Whew. Not as scary anymore, right? Okay. Now, again, I want to solve for x. Usually we'd be trying to get x alone, right? But right now I have an x squared and an x. And usually the best strategy for this is to get everything on one side so it's equal to 0 and then see if it factors, okay? I know, we're factoring again. If you wondered when it would come in handy, here it is, okay? So I'm just getting everything on one side. So I end up with 6x squared. Oh, minus 9x. I almost wrote an 8. Plus 3 equals 0, okay? Now I'm going to see if I can factor this. So first of all, I notice I can pull a 3 out, right? So then I end up with 2x squared minus 3x plus 1 equals 0. And then when I factor this, again, if you need a review on factoring, I'll link a video, especially because this one has a number in front of the x squared, right? So I'll link that if you need it. But this is going to factor down to 3 times 2x minus 1 times x minus 1. And this is equal to 0. Okay? Okay. Whew. We're feeling pretty good now, right? This looks a lot better than that, right? Okay. Now that we're set equal to 0, we can set each of these equal to 0. Okay. Now we can kind of ignore the 3. I could set 3 equal to 0, but that's not true, right? So we don't have to really worry about that. So then I have 2x minus 1 equals 0 and x minus 1 equals 0. Okay. Now I add 1 to both sides. So I get 2x equals 1. Divide both sides by 2 and I get x equals 1/2. Whew. Okay. I can handle that. And then this guy, I just add 1 to both sides, and I get x equals 1. Okay, I am almost done. Okay, the last thing we have to do is when we start our problem and it has variables, it has x's in the denominator, we have to check and make sure that none of our answers are what we call extraneous solutions. Okay, what that means is I can't plug in something for x that will make a denominator 0, right? So I can go plug this in and make sure these aren't going to make any denominator 0. And I am good here, okay? If you want to see an example with an extraneous solution, I will link one for you. But in this problem, for example, if I had gotten the answer x equals 3, this is not my answer. We're just pretending for a second, okay? If I had gotten that answer, see how if I plugged in 3 minus 3, that would end up being 0. It would multiply to whatever those guys are and be 0. And we would have a 0 in the denominator, which we're not cool with, right? It's not okay. Doesn't fly. So if I had ended up with x equals 3, that would be an extraneous, okay? But I didn't end up with that, so we don't have to worry about it, okay? So both these answers are good, okay? I hope this made sense. If you need some more examples, I will link a playlist for you. Thanks.